Welcome to the second presentation on Mayer's multimedia principles, investigating the way students learn by accessing multimedia. There are three principles that we're going to target in this particular module. They are the principles of contiguity, segmenting, and pre-training. So let's take a look. By the end of this course, of course, you'll be able to draw this diagram in your sleep. We keep referring to it because it's very, very important to understanding the framework for designing and learning from multimedia. So, keeping in mind that Mayer's multimedia principles assume that humans process information in dual channels, both a visual channel and a verbal channel, let's remind ourselves very quickly how this works. You, as the teacher, create your content, your instructional content. It is multimedia. You either create printed text or you record narration, and you assemble or create photos and or videos or some kind of montage therein. So you have this multimedia conglomerate then that assumes the responsibility of presenting the content to your learners. Your learners then, your students, input this information via some sensory modality. If they're listening to narration like you are right now, obviously it's going in through their ears, and if they're looking at it either through reading or by watching a video or analyzing photos, then of course they're processing that visually. And remember, one of the key concepts in this part of the model is that perception is selective. And of course, anybody who's married knows that when your spouse starts talking to you while you're watching TV, listening to, let's say, the evening news, it's very difficult to hear both narrations at the same time, what the TV anchor is saying and what your spouse is saying. And of course, the magic happens here at the very end, where all of this information is processed. And I want to point out that one of the key parts of this part of the model is right here, where sounds and images are associated. In other words, if I'm looking at a televised image, a video, a photo, in my head, I'm also generating inner speech about what that is. If I hear sounds, I'm then generating mental images about what I think somebody means when they're reading or narrating something to me. So the point is, there is this bidirectional arrow between these two channels where these associations are generated. Hopefully there is some prior knowledge that gets pulled in, and this little golden egg right here represents the new organized functional model, what many researchers have called a new schema. So that's the model, and we'll break it down as it relates to some of these theoretical principles. First of which, of course, is temporal contiguity. Now, we looked at spatial contiguity last time, where we placed things in a multimedia document near each other, and that was very similar to Williams's proximity principle. But for temporal contiguity, that principle is quite different, and it deals with sequencing. How do you present your content to your learners? Which one goes first? Should they be simultaneous? Is there a difference? Well, there is. And the temporal contiguity principle simply states that students learn better when narration and pictures are presented simultaneously rather than successively. They need to be in the same presentation and not presented in sequence. And that may strike you as rather odd, and there are a few exceptions to that, and we'll discuss those. But remember what's happening here. If I'm looking at visual content and I'm hearing verbal content, that's working on that presentation is working on two different channels, and those channels are then in complement to each other. So simultaneous visual and verbal processing is what results. When you have successive presentation, it creates extraneous processing because there's lots of conflict. And let me give you an example, and I think this will work well for you. Let's say I'm designing a lesson about hurricanes, and the target content that I want to focus on in my lesson is hurricane eye wall generation. So I present this image to my students, and I don't present anything else. They're looking at this silently. Without any narration or without any on-screen text, there is nothing to cue them so that they know what to focus on. For all I know, they could be looking at the map. They could be looking at the entirety of the Atlantic that's displayed here, covered up by this hurricane. They're obviously going to recognize it as a hurricane. They may or may not focus on the eye wall, which is what I want them to do. So that's one of the disadvantages of successive presentation. if you present your visual channel before the verbal channel, in succession, in other words, sequenced like that, learners aren't cued. Likewise, if I were to present the narration before the photo, in other words, they're looking at a black screen, and I start talking about hurricanes and eye walls and storms and weather systems, if I'm presenting this information in narration, or if I present it to them as text and they're reading it, while they read or while they listen, they are conjuring mental images. And those mental images may completely conflict with what this one ends up being when they finally get to see it. And so the result then of having them listen or read before they actually see the visual content is that their mental image may completely conflict with what the actual image presented is to be. And this is what creates this increased processing on cognitive load. And this can inhibit memory processing, and this is one of the reasons that successive presentation doesn't work. Another reason is, quite simply, especially if the information presented is long, students have limited short-term memory capabilities. So if you're presenting sequenced learning, you need to make your segments very short, and we'll see how that works here coming up. But for right now, the principle of temporal contiguity says it's much better to present them at the same time than to present them separately. And this makes a lot of sense if we look at the model again and remind ourselves that the verbal and visual channel are associative. Images conjure sounds, sounds conjure images. And the strength of those two working together, especially when it pulls in prior knowledge, is very effective at creating brand new schemas, brand new cognitive structures. So, having said that, let's move on. What are some of the best practices then? If this is the principle, then obviously a very simple best practice would be to make sure that you present your narration and your visuals together. Whether this is live narration, you're speaking while your visuals are up on the screen, or if this is a recorded video. Make sure they're on screen, that the narration and the visuals are on screen or being presented at the same time. Now, there is an exception. And this exception deals with segment size. When you have just a little bit of content, maybe it's a very simple image or maybe it's just a few words of text, it is okay to sequence them, especially for experienced learners. It's also okay to put them in sequence when learners have some degree of control, and we'll talk a little bit about that momentarily. Let's talk about segmenting first. The principle of segmenting says that students learn better when a multimedia message is presented in user-paced segments rather than as one long continuous unit. And that does make a lot of sense. There are some exceptions though, but the idea behind this is to reduce the amount of cognitive overload by only giving students enough content to process in short-term memory. So by dividing the content, especially if it's a digital multimedia document you're creating and not something live that has live narration, etc., we're trying to divide it up into these bite-sized segments that they can process efficiently. The user can control pacing. When the user can press that pause button on the slider, or they have to click on the button to advance to the next slide, there is a strategic advantage to that. It allows them to move ahead when they're done processing. And this ultimately maximizes the selection process in short-term memory. This is what's happening. As they hear the information or they see the information, if that information is consistent with what they're capable of processing in short-term memory, then selection gets maximized. It also gets maximized when they're presented simultaneously because you have the narration coming in on the verbal channel and you have the visual content coming in, or the pictures or video content coming in on the visual channel. So they're working in complement to each other. When you bust them up into small enough pieces, it maximizes the selection process. So the implications for best practice then are relatively obvious. Chop your content up into small enough segments that facilitate information processing in short-term memory. If possible, and if it's a digital presentation, not a live presentation, you might also consider giving learners control over the pacing. You could put buttons in the PowerPoints if they're navigating a student PowerPoint. They could click on a button to go to the next slide rather than having it advance automatically. So there are a few issues that need to be addressed here, though, and granularity is one of them. How small is too small? What's small for an elementary student is not small for a student at a different level. Can you have too much segmentation before you bore your advanced learners? Are certain content areas easier to make granular, in other words, to shorten the segment size, than others? The answer to all those questions is yes. It's very context dependent. So what constitutes a granular segmentation model is going to depend on your learner ability level and the content that you're teaching, as well as how you're delivering that content. Instructor pacing obviously is an issue as well. If you bust up the content into very small segments, the pacing may have to be very fast to get through them. Or it might be so slow that you end up boring your advanced learners. Again, you as the teacher have to understand the larger context in which this learning object is going to be situated. Obviously, learner experience plays a lot into this as well. More experienced learners require a lot less segmenting. And that's the reason that some of our videos in here are much longer. You folks are mature adult learners, and you have good note-taking skills, we hope anyway, and you're able to digest this information. And if you can't, then all you have to do is exercise your playback control and click the pause button. And this is a deliberate design that maximizes the selection process. Let's move on to the next principle. Pre-training is a very simple construct to understand. Students learn more deeply from a multimedia message when they know the names and characteristics of the main concepts. The strategy is to try to reduce the cognitive overload by allowing them to build prior knowledge. Give them a little bit of information in advance. That then becomes prior knowledge that they can use to help construct with the more complex content that happens later. When you present that more difficult content, having that prior knowledge, even if it's rudimentary, memorized content, it still facilitates the mental modeling. And this is really, really important for young or novice learners. For example, let's go back to our lesson on eye wall regeneration. If this is the concept I want to teach to my middle grade earth science students, I might consider pre-teaching these two really important terms. Obviously, they need to know what a hurricane eye is, and they also need to know the direction, the counterclockwise direction that hurricanes in which they spin. And this is fundamental to understanding the more complex term that we'll get into later about eye wall regeneration. So by building this very simple prior knowledge with these two key terms, and again, we see vocabulary as a very common technique for pre-teaching. That's one of the reasons we do it in this class. All those terms come back up in context later when we're dealing with much more complex content. And by that point, some of that pre-taught knowledge has become prior knowledge that can then help build these mental models. So again, it all happens here at the very end. Those two terms, the anticyclonic or counterclockwise rotation of hurricanes plus the term eye, are combined now in prior knowledge with this new incoming verbal and visual information about eye wall regeneration cycles, which is much more complex. And ultimately, that ends up building these new mental schemas. What are the implications then for best practices? Well, for complex material, design some initial instructional activities that focus on these key concepts. And like we said, especially considering vocabulary. But there are some problems. How do you pre-teach? There is not a whole lot of research that differentiates regular teaching from pre-teaching techniques. So that is still undetermined to some degree by the literature. And we all know, of course, that prior knowledge is not a constant. For example, all of you were asked to learn several terms as part of a pre-teaching exercise for this course. And in that case, I wasn't doing the teaching. You were to teach yourself by looking these up, etc., to try to learn these vocabulary. All of those terms then come up within context of the actual lessons that we're doing in the course later, typically on much more complex topics. But the bottom line is, you might not remember all of those terms, and so prior knowledge is not a constant among students. Some will remember more than others. and some of those terms are stickier than others. And that is just a known limitation of this particular technique. This concludes part 2 of the presentation on Mayer's multimedia learning principles. Please consult the course learning management system site for your next task.